quadratics especially, is that when you're dealing with graphing a quadratic, if it's in that standard form, ax squared plus bx plus c is 0 or y or whatever, let's say it's equal to y for right now. If it's in that standard form, Palmer,
Yeah.
what is the axis of symmetry? Thank you. The axis of symmetry is opposite of b over 2a. Now, what else do you know about the axis of symmetry? Yeah, the vertex lies on it. That means the vertex is, the x-coordinate is the opposite of b over 2a. Use substitution to get your value of y. Also, when you're graphing these things, how do you know if it's a maximum or a minimum? Up like a cup, down like a frown. So if a is positive, we have down like a frown, and we have a minimum. If a is negative, we have up like a cup and a maximum. What's that?
I think you need to say A positive is.
If a is positive, it's up like a cup.
You said
and
the
it's a
opposite
minimum.
of that.
Oh, I did?
Yeah.
Oh, sorry about that.
Mean what I-
I say what I mean and not mean what I say? Go for it, right? So, also, press second calculate on your calculator. There's a minimum and a maximum button. What do you think that's going to find you? What is the minimum? The vertex. What's the maximum? It's crazy how this works out, isn't it? What is the x-coordinate of a minimum?
0, negative.
Quick, you want some math questions? Yeah. Remember, the x-coordinate of the axis is the axis of symmetry. Also on here, do you see a button that says 0?
Yep. Yes.
What do you think that calculates?
0.
Where it crosses the axis. So should we be able to plot and graph quadratics? Real easy. No. Let's take a look at this. Here's what I want to do. I'm going to graph an inequality. I'm going to graph an inequality with a quadratic, which means I graph the quadratic the exact same way that I have graphed it in the past. In this case here, I have y is greater than x squared minus 2x minus 3, which means more or less I can put that in my calculator and start getting some information. Let me figure this out. We have x squared minus 2x minus 3. When I graph that, it looks like this. Oh, let me change my window.
Minus 2x plus. I would say.
Now, if I'm looking at this, I can figure out my axis of symmetry rather easily. Opposite of b over 2a. My axis of symmetry is at x equals 1. Do you guys agree? I know, just by looking at this, I know that my axis of symmetry, the opposite of b over 2a, so it's positive 2 over 2 times 1, which is 1. I know my axis of symmetry occurs, at x equals 1. Okay? I know my vertex is going to lie at, well, that's a minimum, isn't it? Second, calculate. Minimum. Remember what it means for left bound and right bound. What you're doing is you're putting parameters on both sides of the graph and want it to check for the smallest value. Right now my cursor is to the left of where the minimum occurs. Just hit enter. Scroll to the right. Doesn't have to be symmetrical. Hit enter. Guess. And my minimum occurs at 1, negative 4. Yes, sir?
Why don't you just use that same thing to get your axis of symmetry to it?
You can. I'm just showing you guys, with some of these it's real easy to find because it's an even number. It's just real quick. All right? So in this case, I know my vertex lies at 1, negative 4.
Why does not say 1.0?
It does a little rounding thing. They're all like that. You had to take it with a grain of salt, and it is. Now, next thing I want to figure out are my zeros. Come on. Yes, sir.
Can't you just put the 1
You can do that too. It's fine. When I go to calculate my zeros, there's two methods you can do this. If you want to calculate your zeros via the table, that's fine, because the table will give you, the table's going to give you your, what do they call, integers, forgot that, the integer values. I look at my table, I'm looking for values of 0 in the y column. Oh, look at that, there's one at 3. And there's one at -1. Everybody see that? Wait, what were you doing? I'm looking at my window. If I look at my window, my zeros are where y is equal to 0. It works really nice if it's integer value. Here I have -1 and 3 for my zeros. Okay?
Oh, wait, would you look at, like, for an equation like this, wouldn't you look at the 0 and then go directly to that point?
If you want and do the not the trace, but the calculate 0, that's fine. But I also know that I can factor this and I can get zeros that way. So as of right now, I have plotted my vertex and some zeros. Is that plenty for what we need to do? Okay. Think about when you graphed and shaded regular linear equations. How did you tell what side to shade on?
The side 0.
We tested a point. What's a test point that I can use here?
0.
0, 0 again. Because does the graph go through 0, 0?
No.
All right, so you tested at 0, 0. Is 0 bigger than 0 squared minus 2 times 0 minus 3? Is 0 bigger than -3?
Yes.
Okay, so do I shade inside the parabola or outside the parabola? And that's how you shade these.
And it likes to hold stuff.
That's it. You graph them like you would normally, but in this case, we're using more technology to get through the graphing part because we're worried about the shape. You're identifying vertex and zeros, plot them, and go. Yes, we're not worried about shading. Just wait until she wants to. I'll label it. You already Yeah, great question. If it was false, where would I shade? On the outside. Yes, no. It's, your table set might be, hit second table set. Is your delta at 0.5 or something, or is that 1? You're going to have, there's always be a little round here. Yeah.
Oh, okay.
Yeah.
It says my battery's under.
I'll get you some in a second.
Oh, yeah, so that
Same
like
here.
12 times what it was.
What do you think changes when you have systems? Oh yeah, good point here. Are these, do we have to worry about solid and dotted? I think I forgot on this one, didn't I? Oh, should that have been a dotted line? That should have been a dotted line for my parabola. I should have done this. Points off for Murphy. Sorry about that. Okay? Now, when you go to systems, what changes?
You just have more.
You just have more of them. Go ahead, do the same thing like we just did. Find your vertex, calculate zeros, plot your two parabolas, and then use a test point for each parabola to see where the shade overlaps, or if it does overlap. That's what you're doing with this stuff. Okay? So you
Yeah.
do me a favor when you guys are done with the batteries, just throw them in here and I'll recycle them. What's that? It might be, I don't know.
What is because 0,
So it's x squared minus 4, and the other one is negative, bless you, x squared.
that one is really easy to do.
When you have multiple graphs, instead of trying to switch between the two graphs while you're looking at it on the table functions and all that in the calculator, sometimes it's easier just to do them one at a time. All right, sometimes it's a little bit easier. So I know this one we wind up with,
Why does it give you such a weird number?
it always, it's,
I got 6.6976
okay. 7?
That's just 0.
Yeah, it's right about there. So I know this first one, if x is 0, I know that I'm at -4. Yes, sir?
Did you say that if when you plug it in, if it's right, then it's inside the parabola?
Yes. So that's what the first parabola looks like. The second parabola, I know if x is 0, it starts at +2. Or I know that's a point there. My axis of symmetry opposite of b, so it's 1 divided by 2 over -1, so it's -1/2 is my axis of symmetry on that one. So my axis of symmetry there, which means my vertex is at -1/2 and something. Was it -2 1/4?
Yeah, that's fine.
So my vertex is -1/2, -2 1/4. I'm just kind of waiting. Go back to here. I'll use the calculator to get my points. At -2, it's 0. -1, it's 2. Wait a second. How's this one on? Oh, yeah, there we go. So it's up here. Vertex is here, so it's going up like this. Whatever, somewhere in that neighborhood. Now, once again, you get a graph that looks kind of funky. What point didn't go through either one of those graphs?
0.
Okay, test it. Is 0 greater than -4? So this one was correct shading in here going upwards. Is this 0 smaller than 2? So we have the shaded region in here. Okay? That's how you graph these things in 2 variables. There's an x and there is y.
But the second one's a dotted line.
Thank you. All right, second one was a dotted line. That's how this works within 2 variables when you have the x and a y. There are a couple other little tweaks with this when you don't have the y value. I'm going to show you those examples here. We do basically the exact same thing. Yeah?
Isn't it when you divide by negative, the sign switches?
Yeah, but we're not worried about dividing by anything here. We're just
But like,
we're using calculators.
if you did.
Yes, then you would
then
do
have
flip.
so that wouldn't be.
Oh, you just use the same graph.
We're not worried about the, we're looking at the axis of symmetry is the opposite of video over 2a. That still occurs there. It doesn't worry about that doesn't change even though there's an inequality. Even though if you're dividing. Because the axis of symmetry is still x equals a line. It's not like the graph. The graph is the y is less than. The x equals still vertical. Great question. Yeah. Yeah. All right. Now, there's a little slight difference between what we just did and what we're looking at here. The difference here is that notice that there's only one variable. There's just x's. There's no y value. It says less than 0. Okay? The difference when you see a problem like that, it's just saying where, since it's a less than, where is the graph below 0? Between what values is the graph below 0? So go to your calculator. Let's graph x squared minus 6x plus 5. X squared minus 6x plus 5. We have the graph. Remember, we're just rough sketching stuff here. When I do that, we had an axis of symmetry at 3. My vertex would be at 3, what is it? 3, 4, I think. It is at 3, right? Negative opposite of b, so it's 6 divided by 2, so it's 3. 9 minus 19, so it's -4. 3, -4 is my vertex. Remember, we know that's a minimum value because A is positive. You can calculate that in the calculator, it'll spit that out for you. The minimum value is at 3, -4. I also could find my zeros.
Is it dotted line?
It's a minimum, I can calculate. What I did here is I found the axis of symmetry. I know it's 3, and I just put 3 in. I solved it. That's one way you can do it, or you just calculate the calculator. From here, I can also figure out my zeros. This is a factorable equation, isn't it? What's positive 5? You have to be able to get -6. So you have x minus 1, x minus 5. What are your zeros for that? 1 and 5. So I know I'm crossing the x-axis at 1, 3, 4, 5. Do I need to make sure that, do I have to factor all of these, or can I use my calculator? I can use my calculator. I didn't forget. It's a dotted line. Now, because it's less than. All right. Now, where is the graph below 0? Between what values of x? Between 1 and 5. Does it include 1 and 5? No, it doesn't. Why doesn't it include 1 and 5? Because it's a less than. I know that it's between 1 and 5, this graph is below 0. And it's a less than symbol because it's a dotted line. Okay? Does that make sense? I just wrote the word dot.
So if it's a solid line, it's going to be
Less than or equal to.
Wait, can we
Yep.
do that for a second?
Yeah, absolutely. I told you guys that before.
Wait, really? You didn't have to do like the
Yes. Because if you screwed up, you forgot, you just put an arrow saying it's dotted, that's not a big deal to me. I told you guys that. People did it.
you just always just
People did that.
like erase a different section.
Those are the ones that are, those are the intercepts. So when you're looking here, you're finding your intercepts, is it above or below the graph? Well, it's got to be below or less than. See how this is less than?
Yeah.
Where is this graph below 0 is what that's asking you. It's below 0 between those 2 points.
Oh.
Okay? Same thing that goes here. In this case, it's a greater than or equal to 0. So what am I asking? Where is the graph above 0? So you do the same thing. Go to your graphing calculator. We're going to type in the following equation. 2x squared plus 3x minus 3. And I'm going to graph it. Find out where my vertex is. It is a minimum. Move some stuff around here.
It's in a strange one. It's in a strange one.
That's all right. Negative 0.75. What is that? 3/4, isn't it? So that's at negative 3/4. And what was the other one? 1 and 1.25? 4 1/8. What's that? Then calculate minimum. Right, 4.125 is 4 1/8. All right. Now it's up like a cup. Can I calculate zeros? Okay. If I calculate my zeros, I hit second, calculate, 0. I have to find 2 of them, so I'm just going to move this up. See how I've got my cursor above? Go below. I didn't go below. I probably didn't. Once again, second calculate 0. Above. Oh, I hit one button, that's fine. Below. I have a 0 at negative 2.19. Now, would this be included or excluded?
I mean, included.
It's included. So at negative 2.19, I'm just going to leave that, and then I'm going to figure out the other one. Is it okay to round it to negative 2.19 for a decimal wise? It's not an easily recognizable fraction. If it was 2.5, I'd write 2.5. Yes, sir.
What did we just do? Like right
greater than or equal to, so am I including it or excluding that value? Am I putting a solid dot or an open dot? Solid.
So if it was less than, you'd have to do an dot.
Right. And then I do the same thing on the other side. What did you guys get for the 0 on the other side?
0.8.
What was it?
0.68.
0.68? All right. Now, I need to figure out where the graph is above 0. Is the graph above 0? Well, it's above 0 going this way, and above 0 going this way, right? So that means for x values greater than or equal to 0.68, it's above 0. Or x values that are less than or equal to negative 2.19 are values that are greater than 0. Because the graph itself, once you get above 0, that means all these points in here are all true statements. And that's what that is asking you to look for. Whenever it says equal to 0, you are trying to calculate where is it above or where is it below the graph. Use the calculate function to figure out where your zeros are, and you just go through it. Okay? Not so scary? It's a little bit different. You guys probably haven't seen this. I know you've never seen this before.
Where you shape?
You don't have to shape. What you're doing is just kind of figure out. You would if it was the two variable set.
Okay.
But in this case, it's a little bit different because it's asking you where is it above 0. If I was looking for a two variable set, I would be also including all of this down here because it's outside it. But I'm looking for just being above 0. So it's putting like a parameter on it. It's kind of like the linear programming-esque to the quadratic. Which, don't worry, we're not doing any of that with this. What do we got? 10 minutes? Last one. The difference between this one and the one we just did is what? It has an 8 on the other side. It is not straightforward less than or equal to 0, is it? Correct. So what happens here is that when it's not set forward equal to 0 to start, or less than or greater than or equal to 0 to start with, what you do is you have to factor and set number solutions on a number line. Let me explain. When we set this one up, this is going to be easily factorable. You get x squared plus 2x minus 8 less than or equal to 0. What times what is negative 8? You add together to get positive 2. 4 and negative 2, good. So x plus 4, x minus 2, less than or equal to 0. Now, instead of setting it equal to 0, what do I set it equal to? You know how when we would find our zeros, we'd set these both equal to 0? Now I set it as this. X plus 4 is less than or equal to 0. X minus 2 is less than or equal to 0. It's making you guys create a number line by doing that. Instead of setting both terms to find the 0, you're setting both terms to find the inequality. How do I move the 4? So I get x is less than or equal to negative 4. How do I move the negative 2? I get x is less than or equal to 2. That's what that would look like.
Wait till you get 2 less than.
Sometimes. So when you think about what would be the true solution then? Anything less than or equal to negative 4 would be the real solution that would fit for both of them. Because on a number line, if you drew this out, you have negative 4, solid, going this way. You have 2, solid, and going this way. They don't overlap until they get out over here. That's what you're just being able to write out. All right. When you're doing these, as far as the inequality stuff like this, these should all work out to be factorable. If not, use quadratic formula. Yes, sir?
So then what would you write for the answer?
Just those x is less than or equal to 4, negative 4x is less than or equal to 2. So I got to worry about. Okay. I was just showing you graphically what it means, what you're doing. The only crazy step here is remembering that you just, instead of setting equal to 0 to find zeros, you're finding the inequalities. Okay? Give you guys a couple of these to try tonight. It's basically a couple of graphs and then 3 of each of the other types of the algebraic styles. Okay? Rough sketch your graphs, guys. I try to make sure I gave you values that look clean. If they are nasty looking stuff, use your graphing calculators just like we did in class to get those decimal equivalencies, and that's perfectly fine because we're just trying to get in the habit of understanding what it means to press the buttons correctly to find maximum, minimum, zeros, things like that. Okay?